Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Examine the continuity of the function h of x equals e to the power x into tan x, right? So again, this looks like a product of two functions, right? And how do we go about solving this? So if again I apply the algebra of continuous functions, what is my f of x? Is e to the power x, right? My g of x is tan of x, right? Can I write this as sine of x divided by cos of x, right? I'm going to write it that way. And let's treat f of x separately and let's examine whether this particular function is continuous, right? So I know that my e to the power x is continuous, right? So let's write that out. It is continuous for all x belonging to R, right? And I don't see a challenge because it e is a constant and e to the power x is for any x belonging to R, f of x has a finite number, right? And therefore we know that e to the power x is a continuous function. So let's write that out. X belonging to R. Now let's come to g of x, right? Now, what is g of x? G of x, I have represented this as a function of the form a by b, right? And what is a is my sine x, and what is my b, which is the denominator, which is my cos x. And within g of x, I'm going to apply the fourth rule, which is let me take a pen and highlight this so that it becomes a lot more clearer. I'm going to highlight this one, right? So f by g is continuous at x equal to x naught, provided g of x is not equal to 0. And so when I represent tan x as sine of x by cos of x, whenever cos of x, which is in the denominator, takes a value 0, then I know that this function tan of x, which is nothing but my g of x in this case, let me write it out, which is nothing but g of x is undefined, or rather, uh, let me call it discontinuous when cos of x equals 0, right? Otherwise, sine of x and cos of x individually are continuous functions. But when I'm going to combine them and represent it as tan x, which is my sine x by cos x, then the function becomes discontinuous whenever cos of x equals 0. So we know when cos of x equals 0, right? So the function is discontinuous at points wherever cos of x equals 0. And whereas cos of x equals 0, we know that cos of 0 is 1, cos of pi by 2 is 0, and then cos of pi is, what is cos of pi? Cos of pi is also a finite number. And cos of 3 pi by 2, which is, an odd multiple of pi by 2, is again 0, right? So g of x is discontinuous whenever, and similarly you can try substituting values. You will see that whenever x belongs to an odd multiple of pi by 2, which can be represented as 2n plus 1 into my pi by 2, right? So pi by 2, then I know that my cos of x takes a value 0, right? So you'll have to remember one thing, folks. Cos of x by itself is a continuous function, right? But when I'm going to put it in the denominator, whenever cos of x equals 0, then the whole function sine of x by cos of x, which is my tan of x, becomes a discontinuous function at those points whenever x belongs to an odd multiple of pi by 2, right? So I have the answer for my g of x where it is continuous and where it is discontinuous, and I have my answer for my f of x, which is simple and straightforward, which is continuous at all points, right? So to this I apply the product rule, right? So like I mentioned in my earlier videos, when f of x is continuous at all points and g of x is discontinuous at a particular point x equal to x naught, then f dot g will also become discontinuous at x equal to x naught, right? So by that rule, which is nothing but, again, everything boils down to the algebra of continuous function, which I have listed down on the screen for you. So all that I mean is f of x into g of x is continuous at all points r except, so when we rewrite this, let's rewrite this. F dot g, which is nothing but my h of x, is therefore continuous at all x belonging to R except, right? When I write this, I will have to write it like this, right? Except odd multiples of 2n plus 1 pi by 2. Pull out my flower bracket. Let me represent this within the flower bracket, right? So that's how we write this, solve this particular problem. And we have one more thing left. So we know what is R, but we also need to write down what is N, right? And what does N belong to? N belongs to the set of positive and negative integers, right? And how do we represent that? Z, right? So let me call it out here. Set of positive and negative integers, set of positive and negative integers, which includes 0 as well, are represented as Z, right? So that's all we have in this particular video. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.